there you have it. That's how you install PostgreSDB, create a database, and then start running your Python automations on a schedule. FinTech family, how are you? Today I'm going to be showing you how to set up Python automations in the cloud and also how to automate your VPS setup. So hardening SSH, adding users, setting up Postgres, all that good stuff. First, we're going to be building that time series analysis tool locally, set up the database. Then we're going to set up our VPS on Linode, do all of our bash scripting for user setup, SSH hardening, auto updates, you name it. And then last, we're going to be deploying our automations from the part one and setting up a database in the VPS. We're going to deploy everything to the VPS. Now, this video is really about deploying automations. It's not about doing analysis or making investment decisions, but to give you a little more color on the project, we're looking at equity sector dispersions. So we're going to be looking at, let's just say, an index. Then we're going to look at the individual sectors like real estate, communications, industrials, and see here you can kind of visualize the relative performance of each of the sectors. We're going to keep track of that. And then lastly, all the sectors are made up of individual holdings. So we're also going to look at holdings level performance dispersion against the sectors and against an index. So if you've heard of the Spider ETFs, they do have sector ETFs. If you come over here to sector tracker, you can get a visual idea for what this project kind of can show you. So here we have the S&P 500 index. Last day is up 1.5%. However, relative in the one-day look-back period, consumer staples is flat. So you can get an idea for relative under and over performance on a one-day look-back. It's historical, right? But then inside of each of these sector ETFs, you have a bunch of different holdings. You can just see how these sector ETFs are made up. So while we're here, to access the holdings, if you go to ETFs here, you click into the actual ETF, and then you click into holdings. You can see here's the holdings you can download in a CSV file. And then all I've done is just clean that up. I'm not saying it's accurate, but I went through all the sector ETFs and grabbed out all the holdings. And I put them into this ETF holdings.py file. So here in this file, we're going to have our index ETF tickers. It's just one. And then here I have the sector ETFs. There's 11. And then within the sector ETFs, you have the individual holdings. So here ETFs holding, it's not a list, it's a dictionary that's made up of here's our key, and then the value is a list of the underlying holdings. All right, now here is our main script. If you can believe it, I shot this video for 45 minutes and it's so hot in here, only to find out the microphone was off. So let's run it. Here we have our imports. Here we have our .env. So inside of the files, oh, I haven't even shown you how to get the files. I'll put this up on GitHub. You can either download the files directly or git clone it locally. You're going to see some of the files, but not all of them. We have our ETF holdings here. We have our main script as the sector performance. Then I have little guides on VPS setup and Postgres setup. I have our requirements.txt file, config.py, which looks exactly like the .env file, and then the actual VPS automation, which is going to be our VPS setup.sh. You won't see the cron output. You won't have this sector DB dump. You'll have to make it yourself locally and then migrate it to the cloud. Or you can just set up a sector DB in the cloud and run it from there. So awesome. Do any pip installs you need to do. We're going to just load our database URL. So if you want to get a feel for what a database URL looks like, so if you don't want to do all that with your env file, you can just import from config.py, or you can just assign a string here. So let me quickly run you through high level of how this project works. So I showed you all of our symbols here. What we're going to do first is just merge those all into one big list so that we can use that list to grab the time series data. So here we'll go one by one through the list. We'll get the time series data. Then we'll calculate the rate of change on that. We're going to store everything in a nice list that's organized to the database schema so that we can update or insert all of that information into our database in one go. So at a high level, that's how that works. What I'll do here is just run all of those functions. Next, I have our sector mapping. The sector mapping, what it tells you is like, hey, what's the actual long form description of the sector ETF? So here, XLK corresponds to technology. I think it's correct, I'm not sure. And then down here, we have our time frames, which are our rate of change look back periods. So our 1 day rate of change, 5 day rate of change, 20-day rate of change. There we go. So here we have our first function, merge symbol info. We pass our index ETF tickers These are both lists. And then here we're passing in the dictionary. If you want to get a feel for that, you can just look at your ETF holdings file. Here we have a blank list where we're going to store everything. So here we're going to go through our index ETF tickers. There's only one. We're going to list the symbol there, our symbol type, and then here from our sector mapping, we're just going to get the description, market, and then our parent ETF is none. Next, we're going to go to our sector ETFs. We're going to go through each. Last, we're going to go through our individual stocks. So remember, this is a dictionary. We're going to go through each sector here, and then we're going to get the individual holdings from each. So for each individual holding per sector, we're going to create an entry in our list. Then we're going to have our sector name. So what sector does that stock belong to? And then we're going to have the parent ETF, which is our ETF symbol. We have our sector name here and then our ETF symbol there. So here's what it looks like when it's all done. Here's the beginning of our database schema. You can see the 4 different, would-be columns. Next, we'll just create a quick REST API client. This part is modular, so if you need, you can swap out the data source you're using as we calculate the rate of change data. So to calculate the rate of change for each of our items in our list here, we're going to pass the list, and then we're also going to pass the time frames we want to compute. So like I mentioned, we're passing in our symbol information and our different time frames. For each symbol, we're going to go in there, we're going to request the time series data. So just to get a look at that function here, we're just going to Polygon or setting our from and to dates. I've made videos on how to request daily time series data from Polygon. The videos are in the playlist. So we're going to go through all that effort to get our price data. So if there is price data, we're going to go back to each look back period and then calculate the rate of change. So the rate of change function is right here at the top. It's very simple, and it calculates our rate of change over the past n days. So 1, 5, 20, etc. After we calculate each of the rate of change lookbacks, we add it to the dictionary for that ticker, and then we also update a data as of date. So if this is a Sunday and we're using data as a Friday, it'll return Friday's date because that's the last date in the index. And so if there is no price data, then for our look back periods, we're just going to put none. So it'll be none for all of the look back periods, but it'll still have the schema that allows us to insert or update it into the database. So once you're through running that, here is our updated list, and here is like one item in the list. So I included these 2 lines of code here if you want to look at a specific symbol. So here's SPY, and then here's a symbol that no time series data was returned for, bf.b, some B shares. Here you can see everything is none, but it's in a format that will still match the database schema, so you can still upload this row to the table. So up next, we're going to be working with this database, but we don't have a database, so I need to make sure Postgres is installed here. All right, so I opened up a new Google. We're going to look at Windows installers, and we're going to try to just run something. So let's see. Here is our PostgreSQL. Let's do Windows. All right, so here is our download from EDB. Let's give it a go. All right, let's go. So here I'm just creating a password for a super user. And then here is our port information. So I just aggressively click through everything with zero regard for anything. Oh fam, we are gonna be here for a minute. All right, I'm just gonna unclick that one and click finish here. Let's fire it up. All right, so here we go. So here servers is asking you to enter the password. I'm just gonna do the same sudo user password that I created earlier. What I'm going to try to do is just create a database here, right clicking, and then create database and give it a go. So I'm just going to call it sector.db. So once I fill in sector.db here, if I go to SQL, I can see the code that it's going to run. So I'm just going to press save, and look, you can see it created a database here. So what we need to do to create our engine here is we need to define our database URL. This is where you would change the values that are in your .env file or your config. So what I'll do is I'll probably just update the .env file, but I'll probably just manually write it here for now. So here Postgres is our username, and then here it would be our password for the super user that we created when we did the installation. And then If you didn't change the port number, that should be good. And then here's the name of the database that we created. So this is what our database URL is going to look like. I'm going to try to use this inside of our create engine command. Okay, here we go. That would be nice, but we don't have psychopg2 installed. So here I'm going to come over to environments and try to open up a terminal. So you can see it's downloading and installing. Let's give it a go. So here I just imported it. It appeared to work. So let's try it again. So again, we're just creating the engine here with our database URL. Did it work? I don't know. We're going to give it a go. We're going to create a session here. And then we're going to create our base class because we are going to create our table schema here. And then we're going to, of course, just create that table in the database. So let me go ahead and run these lines together. So of course, I never updated with the proper password. So I didn't update the password, so I'll do that now and then run it through. So now that I've updated the password to match the super user, I'll do that. And of course, that doesn't work, so that's just dandy. So I'll just save you a bit of headache. Before we try to create a table, we need to create a user or a role that has privileges on our database. So let's create a user so that we can authenticate when we're doing the create engine. So what we're trying to do here is create a user. This command wasn't recognized. We're going to take a look about adding our Postgres to our path. So let's go ahead and search environment variables. So under environment variables here, we'll go to path and then we'll click edit. Let's do new. So here's the path we want to add to our path variables. It's under C, program files, PostgreSQL 17 bin. So I'm just going to copy as text, and then I'll return back over to our new window, paste this in there, press OK, and give it a go. We'll exit out of this terminal. So instead of opening a terminal from our Anaconda environment here, I've opened it just from our main CMD. So if you go here and then you just type CMD, you can open up a fresh command prompt that's not associated with any of these Python environments. It's going to ask for your password, which should be the Postgres password that you set during the installation. Okay, so here you can see we are logged in as Postgres user. That was a great success. Now we just want to create our user. I think I had the commands here in the setup. So we're going to create a dev user with password dev password. And then we are going to grant all privileges on database name to our newly created user, dev user. So we did that. Exit, that should get us back to our command prompt. Okay, great. So that was kind of messy. Let's see if we can actually create the table now. So I'm going to update our database URL with the new user and new passwords, so dev user and dev password information. So here's the updated URL. So let's give it a go. We're going to create the engine and then we're going to create the table. So okay, so I went through a little bit of headache. What we'll do, we'll just go back here and we'll grant the public schema to our dev user. And then one more. Right, so I ran those two lines. I'm gonna get out of there. Okay, so when I try to create the table, I get this permission denied for the public schema. So here in SectorDB, if we go down to schemas, you can see the public schema, right click, properties, and then we go to security, which is privileges. We can add dev user. We want to grant all. Let's just do it all, baby. And then we'll save it and we'll see if it works. It does. So it appears to have worked, but it's giving us a little bit of headache about where our declarative base is coming from. So you may be able just to get rid of that if you really need to. And you can also import declarative base from here. So it may not be from here. We can give it a go, and then let's just run the whole thing, and it doesn't give us any warnings, so that should be good for now. I ran the create table. If you want to look it up, you can just click query tool. It'll open up a SQL editor. So I ran that, and then here are our columns. There's no data in the table yet. We want to insert our data into the table. So here is the ticker data that we're going to be inserting. It's a list of dictionaries that fit the database schema that you see here. So here's how this function works. Here we're going to be passing it this data list that I showed you, creates the session, and then here is the model, the table model that it's using here. For every item in our data list, we're going to go and insert into our table. Now, if there's a conflict, instead of insert, we're going to update. And then here we specify that if there's a conflict on symbol, so that would be like our primary key for this table, then we are updating using this dictionary here, which matches the schema of the database and also from our data list. So once we went through all the items, then we're going to commit that to the database, roll back as needed, close out our session. And so then here we're going to run the upsert. So it says it was successful for all 515 records. I think we can refresh it. So then let's just rerun the query, and then you can see we have data being populated into the table. So you can see our symbol types, all the rate of change information. And then on the end here, we can see our data as of, except for it looks like our last update is not working properly. So I think whatever was provided by default is not working. And I'm just going to run it again to see if when it does the actual upsert, if it fixes the timestamp. So definitely could fix that up. So now that we've created our engine and we have a connection to the database, we can run queries directly so we can see how many rows there are. So let's just say we wanted to query a row based on a specific ticker. We could just run this command here. It's going to give us the information for Apple. So now that we've got that program working nicely, we want to get on an automated execution schedule. So it's not a Mac, so I can't use cron job. What we're going to do is use the task scheduler built into the Windows operating system. So I've just imported here, and then this line, I'm going to just change the directory to be our working directory. In case it's unclear for when we're executing this through the task scheduler. So if you search Windows here, task scheduler, you can open the task scheduler application, and then we'll want to create task here. I think I'm just going to kind of give this a go. So we'll just name this sector DB, and then triggers, I guess we can just do every 5 minutes. We're going to do this daily, repeat task every 5 minutes for the duration of indefinitely. We'll say okay. So here's the details, and then we want it to do a specific action. So we want to specify which Python to execute from, and then in the arguments we'll specify which file to execute. If you open up a terminal, type where Python, it'll give you some different Python interpreters that you can run. I'm going to try to use this Anaconda. So I've just navigated to the Python here that we'll use, and then in arguments I'll put the file name. So the next here in add arguments, I'm just going to have the full path to the Python file that we want to execute, which is this file here. Yeah, so that's annoying, right? So the reason this wasn't working is because our trigger's at 9:03 and it already was 9:03, right? So what we'll do is we'll set this to 9:14. So what I did was I changed the trigger time to 9:14 instead of 9:03, which was in the past by the time I was done creating the actions. So I'm hoping that in the next 10 seconds, this will begin to run, and then we'll see the update to the database. Awesome, so here it goes. It opened the Python terminal and it's running the app. You can see it there. Awesome, so as soon as that's done running, it just shuts the window down. So we should be able to see this update. So if we query the database again and we check the time update, we can see that it's been updated recently as of 9:15. So now we know that our task scheduler works. So it's going to run every 5 minutes. You would probably want this to run once a day. There you have it. That's how you install PostgreSDB, create a database, and then start running your Python automations on a schedule. Next, we're going to be creating a VPS, running bash automations to set up everything quick, clean, and fast. Hang on for the next video.